The following program is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
Welcome back to Element 14 Presents. My name is DJ, and today we're going to talk about nostalgia. Specifically, my nostalgia for the early 2000s and a hapless alien invader and his failed attempts to take over the Earth. I'm talking about Invader ZIM. This show might have gone off the air more than a decade ago, but it's lived on in my heart and in hot topics around the United States all that time. This weird show had an outsized influence on my childhood to build crazy gadgets, and well, here I am. In a strange turn of events, Nickelodeon has decided to make a TV movie all these years later. So, as a gift to my childhood self and to ZIM fans around the world, I'm going to be making an animatronic version of GIR, ZIM's robot sidekick. Let's jump in.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
GIR's massive eyes and wall-eyed stare are some of his most prominent traits. And as with the design of any character, special care should be given to the shape of the eyes because that's what people focus most of their attention on. So that's what I designed first. GIR doesn't have pupils or eyelids. Instead, to emote, he changes the entire shape of his eye tubes to match whatever expression he's trying to make and changes their color. Now, right off the bat, we can tell that they don't work in any mechanical sense that I'm aware of. And while I would have liked to use LCDs for the eyes, like how I did with my friend Roberto right here, that's not really an option. For one, this design has huge bezels and the eyes can be scaled down and are relatively small, whereas GIR's eyes are nearly flush and in my design over 125 millimeters in diameter. Since GIR's eyes only need to swap between two different colors, we can easily solve this by using a strip of RGB LEDs. We only need to show red or aqua, which are the two different states that his eyes are between. And I'm going to glue this strip of LEDs to the back of each eye, and we can make that one continuous strand. So we need to use a minimum of pins, which makes it really easy to do. Now, in order to diffuse that light, because the light coming off the LEDs is just too harsh, and also he needs eye caps, I'm going to be using some polycarbonate. So I used my CNC to make two perfectly round discs because I'm terrible at using the bandsaw. So I've got my two round polycarbonate discs, and then with a little sanding with my orbital sander, now they're diffused and ready to go. And the eye tubes themselves just pop into the sockets of the head and are mounted to each other using this bracket, which then will mount to the neck mechanism, which I'll talk about in just a second. I don't know if you've noticed this, but GIR's head is absolutely massive. Thankfully, it's mostly just empty space, which is good because I want to move it around. And in order to do that, I'm going to be using two standard servos. And in order to get the range of motion that I want, I'm going to arrange them in a pan-tilt mechanism. So I need one servo that will allow me to pan his head back and forth, and that will mount onto the neck coupler, which allows for some of the wires to come through the body, but we'll talk more about that in a bit. And then we mount that to the next servo, which is our tilt servo, via these two brackets that connect to the screw points on the servos. And the tilt servo has one big L bracket, which allows his head to tilt and provides a solid mounting point for GIR's head so that it rotates about his neck. The only compromise I had to make in the design for this was I did have to include a slot at the base of his head so that it could actually travel about that point. And speaking of his neck, I needed to reinforce it because you might notice it's also very tiny. This couldn't just be a 3D print, it would be way too weak. So I cut a piece of aluminum tubing and wedged that in between a outer 3D printed shell so that the aluminum tubing takes all of that stress as opposed to a very tiny cross section of plastic. I wanted GIR to speak for sure, and while his mouth does open throughout the show pretty wildly, it does so seamlessly, and adding hinges in real life would just look too weird and would change the character quite a bit. Thankfully, his default mouth shape is this weird little stitch design, which is actually really weird for a robot, and I never really thought about that when I was younger. But it's a nice opening that we can stick a speaker behind. Now, there are a lot of different ways to make sound using electronics. And in this case, I wanted to use a separate chip just for doing the sound effects, because while there are a lot of modern processors that can do functionally multitasking, streaming audio from an SD card or a memory chip is still pretty intensive while handling all the other tasks that could be going on. So I'm going to be using the Arduino MKR0 as my standalone audio processor. And I went with this because, one, it's fast enough and cheap enough, and it also has a built-in SD card, so we can store the WAV files that I'm going to be playing back directly onto a micro SD card, pop that into the Arduino MKR0, and if we want to play the audio, it also has, or the Atmel SAMD21 chip has, an I2S interface, which is a nifty digital audio bus, which is really easy for connecting amplifiers or microphones and things like that. So I'm going to be connecting an I2S amplifier to the Arduino MKR0 and a little 5-watt speaker to that amplifier. Believe it or not, GIR's arms were actually the most significant constraint when designing this build. I had originally designed GIR much smaller, but then I realized that his wrists would be paper thin. And I wanted everything to be as scaled as possible without compromising the design, so I bumped up his overall proportions so that he's a little over half a meter tall. And once I did that, everything was a little bit more sturdy, although his features are still absolutely tiny. And I ended up 3D printing his hands, his little wrist ball things, and his arms. And these mount to his shoulder balls, which cap onto micro servos, and these will provide the motion for his arms. And those micro servos just glue into some plates on the inside of GIR's body. GIR's legs provided an interesting challenge because, well, he's effectively floating above them. There's no mechanical connection. So since there's no attachment there, we'll need to support his body externally, and his feet will just need to rest on the base of something. Other than that, his legs are really simple. They're just tapered cone shapes that I 3D printed and then mounted to a base. So in order to actually raise GIR's body up, I decided to go and cut some ABS tubing just because I had it lying around, and that will keep his body floating above his legs. It just mounts into the back of his body for some nice support. Now, if we look inside his body, you'll notice some magnets, and that serves two purposes. One, it makes it really easy to get to the wires on the inside and rearrange things if I need to. And two, GIR's design doesn't have any visible screws, so this helps keep him more aesthetically accurate. So speaking of the base, the tube actually rests in a base box which holds all of our power electronics. So I've got a power entry module at the rear of the box, and this allows me to quickly connect and disconnect the AC power connections to the 5-volt AC to DC power converter. This will supply all of our current for all of the electronics inside, and while 5 volts is at the low end for servos, it's more than enough power for everything in this build. Alright, so there are 3 pieces of code that really tie this whole project together. On the audio side, we've got the Arduino MKR board, which is just looking for commands and will play audio files via its I2S port. And for the main controller, I'm going to go with the Particle Photon, which is a really handy-dandy development platform that has internet connectivity. It's got a built-in Wi-Fi radio, as well as a really well-documented API. I'm not going to go into all of that because their website goes into it to as much detail as you would ever want. But needless to say, we can read the state of variables or call functions, which is what we're going to do to create a wireless remote, So if we want to control the LEDs or the servos or send along audio commands to the Arduino MKR board, that is what the photon is going to do for us.
Okay, so last but certainly not least, here is a look at the actual GUI we're going to use to control everything. So before we get to the visual layout, let's talk about the code. Now, I'm not going to go into too much about the details of Kivy. You can check out their website if you want to find out more. This isn't a tutorial, but it's pretty fun. You'll notice there's actually not a whole lot going on right here. This is our main function. This is our GIR command. So all this is going to do is send a post request, and that post request will just send some data to the particle cloud. Right now I'm just going to have it print out because I don't have all the electronics running and it will not work properly. So you might notice there's not anything relating to the GUI here, and that's because Kivy has an interesting way of going about this and has its own KV language, which is kind of like markup. And let's take a look at one of the buttons. So you define widgets. In this case, I've got a button widget, and we can just give it a label. So here I've got this upper left label here and events tied to those widgets. So on press, I can call a certain function, and the only function I've got is that GIR command function. And for the head, if we want to move it to the upper left, we need to send some data for the photon to control the servos. So I just say head, move the X servo to that position, and then head, move the Y servo to such and such position. And this is how it operates for most of the commands. The only difference being how things look for sliders. So I've got some sliders right here for the arms, and you'll notice it's just sending different requests for each arm, or if I wanted to move them at the same time, this one will move both or reset them to the middle. I've also got some buttons here for controlling the audio, and one more button that controls the eyes, and that just toggles back and forth.
Okay, so let's recap the electronics because it's hard to see everything as it is in place, so let me go over it in this block diagram I created. So starting out, we've got our AC power, and this connects to our power entry module at the base of the unit. This connects to the AC to DC converter, which provides a 5-volt source for all of the rest of the electronics. Our main controller is the photon, and this directly connects to the LEDs, and the LEDs are in 2 strips of 16 LEDs each. It also directly connects to the servo, so we've got a servo for each arm and 2 for the neck. Now, via the UART, the photon connects to the MKR0, which also has that micro SD card popped into its slot, as well as the I2S interface, which connects to our amplifier, and this connects to our speaker. Okay, so let's take an overview of how the software connects all together because it's a little bit harder to visualize. At the user, we've got our GUI, which is just our Python application using Kivy, and every time we press a button, this sends a post request to the particle cloud, and all that really is sending strings to our sketch within the photon. So the photon parses those strings, and if it's a command for the eyes or the servos, it will just directly execute that. Or if it's an audio command, it will send an additional command via serial to the sketch running on the MKR board, which will play back our audio files. You know those times where you want things to work and then they just do? This isn't one of those times. You see, I wanted to use my Windows laptop to control the application because, oh, that would be simple, that would be easy. But to put it in PG terms, Windows is being difficult. And rather than waste my life trying to work around the challenges that Windows has with simple applications, I'm not going to use that, and I dragged my desktop all the way down here to control GIR. So let's do that. All right, so here we are. I've got the application running on my desktop and GIR is powered and ready to go. So let's do a quick test with the eyes so we can toggle them between red and aqua, which is what we want to do. And let's do a quick audio test.
GIR, reporting for duty.
I think he's ready.
I want to watch the Scary Monkey Show.
All right, audio sounds good. And let's move, oh, not that position. Let's move the arms. Alrighty. So the arms will slowly interpolate between those positions, and we should be able to move both of them at the same time. One after the other. Oh, you're already in that position. All right, so let's look down. I mean, up. Let's move back home. Look up. Let's look right. A little bit. He almost pops his arms out of the sockets. I think his head is quite a bit heavier than I originally imagined. Yep, there it goes. All right, let's move. Oh, let's move that back to the home position. His head is a little bit too heavy, and everything's just a little bit too springy than I'd hoped. But I think that's pretty darn close to what I wanted to happen, except for the arms falling off thing. All right, that about does it for myself and GIR here. I am so satisfied with how this thing turned out. Granted, I still have some kinks that I need to iron out. This isn't going to be running standalone at a theme park anytime soon, but I learned a thing or two, and I'm definitely going to be putting those skills to future use. I'm not sure that there's much that could be done about the bobbliness of his head, considering how massive it is relative to his body. I'm sure I could put some metal parts in there to make everything a bit more rigid, but considering it's 3D printed, I'm satisfied with how it works. Speaking of which, if you want the 3D files or the code, you can go to element14.com/presents to grab them. And let us know at the Element 14 community if you've ever made something that you love come to life with electronics. All right, that's all I've got for now. I'll see you guys next time.